Hello guys. So we want to look for ANOVA analysis. This is a one-way ANOVA, which is a ANOVA analysis on variance. We can call it one-way ANOVA, or we said one-way classification. One-way classification. All right. This one-way ANOVA, one-way classification. This is the other name, or we call it one-factor experiment. One-factor experiment. So we can call it one-factor experiment. Now, in this one-way ANOVA, we'll be talking about treatment between and treatment within. And that was lead us to this table of ANOVA analysis. So we have this table here. So in this table, the first column here, we have the variation. We have the variation. So in this variation here, this is when what we're talking about between treatment, between treatment. So between treatment and this between treatment, we can represent it with V subscript B, and here we have variation within treatment. Within treatment, then we can like to represent V subscript W. Then finally here we have the total variation. We have the total variation. We can just make to represent V. Now here we have degree of freedom. The second column will contain the degree of freedom. So in this degree of freedom, for variation between treatment, we can have it as A minus 1, whereby A stands for the number of the group, stand for the group number, or we say the number of row. Then variation within the degree of freedom is given as A into brackets B minus 1. That is, this B is the number of observation in each group. Then we have A, the number of group, B, the number of observation in each group. Then finally, for the total, we have A multiplied by B minus 1 as the degree of freedom. Now the next column here, we have the mean square. We have the mean square. So the mean square for variation between treatment, you can have it as V subscript B divided by A minus 1, which is this degree of freedom. And this VB is the value we got here for the variation between treatment. Here, we're going to have VW divided by this degree of freedom, which is A into bracket B minus 1. Now, for this total, we do not need mean square for that. And finally here, we have F statistics. Yeah, how do we get the F statistics? If let this to represent, we said this is equals to S square by subscript B, and we let this one to represent S square by subscript W. Therefore, for us to get the F statistics here, we can now have X bar square subscript B divided by X bar square subscript W will give us the F statistics, with a minus 1, comma, a into bracket b minus 1 degree of freedom. That is, this a minus 1 and b minus 1 degree of freedom will give us this. Now, how do we get the total variation? Now, let me put that here, or let's say the total variation, which represents V equals to, that is how to get this total variation. We're going to use this formula, say summation j dot k into bracket x of j dot k minus x bar raised to power 2. That is, x j dot k means each value in the groups minus x bar, the mean of the whole group. Then we square it. The summation will give us that. Now, for us to get variation between treatment, which stand at v subscript b, that is to get this value here, we're gonna use this formula. Say this is equals to b, that is the number of observation in each group, summation j dot into bracket x bar j dot minus x bar all raised to power 2. And what do we mean by here? The mean in each group minus the grand mean, that is the general mean, square. When we submit everything, it will give us this box here. Now we need the variation within treatment. You can just say variation within treatment, which stand as V sub W, that is this box here. Formula, we can use this formula to represent that, to say V minus VB. And we'll subtract variation between treatment from the total variation, definitely is going to give us this box here, this column here. And we should not forget that our A is the number of group we are considering, whereby B is the number of observation in each group. There is another formula of calculating this, but we're going to use this first, then later we are going to use the other formula. In other way, we can call this as sum of square regression. We call this sum of square error. Let me form another table here, another short table here that will represent everything we've done here. So we have this. Let me cut this here. Yes. So we have another one here. We have another one here. Now here, that is that. For that, this is our f, and this is our source, or let's use this as a sum of square error. We can have our source here. All right, so this is our source. Let me form another column here. So now, if this is our source, then here we have a treatment. We have a treatment, we have an error, and we have a total. So in this case now we have sum of square, SS, sum of square. Here we have SSR, sum of square regression, SSE, sum of square error, and we have a SST, sum of square total. Now then we have the degree of freedom. So we have the degree of freedom for regression, degree of freedom for error, then we have the degree of freedom for total, and finally we talk about mean square. In here we have mean square regression, and here we have mean square error. And for us to get the F statistics, we say MSR, mean square regression, divided by MSE, mean square error. We're still doing the same thing here. Now we're gonna use our example now to do what we are trying to get from this point. And as we can see here now, using the following data, perform a one-way analysis of variance using alpha equals to 0.05. So we're going to use this table now. So the first thing we're going to do here is to get the total here. We want to get our total. We are using this table and we have three groups, 1, 2, 3. And in each group, we have how many observation? 1, 2, 3, 4. Which means here our A equals 3 group. Then we have B, our B equals 4 because we have 4 observation in each group. Then we need the total. Let's form the total here. All right, let's call this one T. Let's say stand for total. 10 plus 2 plus 5 plus 9. This will give us 26. 7 plus 4 plus 2 plus 5. That will give us 18. 13 plus 6 plus 8 plus 4. That will give us 31. So here now, the grand total here, we have a 74. If we add all this together, we have 75 rather, sorry. We have a 75. This is our grand total. So now, we cannot say, and from the formula, we need the total variation. And the total variation is given us, we have total variation first. Total variation. So we have V equals summation into bracket xjk minus x bar all raised to power 2. Now we need x bar. That is the mean of this. Since we already know the grand total, so now we can say our x bar equals to summation x j dot k divided by n. Let's call it n. And if we don't want to call it n, our this, what's it called? N equals to a multiplied by b. That is the whole total number of observation. So having it that way, you cannot say this is equals to 75. The grand total, which is summation xjk divided by n. 1, 2, 3, 4, 1, 2, 3. If we multiply 3 by 4, we're going to have 12. So this will give us 12. And if we divide it further, so this is going to give us 6.25. So that is our mean, the grand mean. So now we are going to subtract each value here from this mean, then we'll square it. We're going to each value here minus mean raised to power 2 will definitely give us what we need here. So that is our total variation. And so we have V equals to, the first value here is 10. So we have into bracket 10 minus 6.25 raised to power 2 plus the next value here 2 minus 6.25 raised to power 2 plus the next value here 5 minus 6.25 raised to power 2 plus the next value, which is 9. Then after 9 we take 7 up till we reach 4 plus dot 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 plus the last value here, which is 4 minus 6.25 all raised to power 2. And what that means is that we subtract each value. After 9, we go to 7, 4, 2, 5, up to the last value here. So, and that is why we have a 4 minus 6.25. So this dot 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 now means the other value that I could not write here. And if you do it this way, we're going to have V equals to 3.75 raised to power 2 for this plus minus 4.25 raised to power 2 for this plus this now. So into bracket 5 minus 6.25, that will give us minus 1.25 raised to power 2 plus dot plus the last value here, which is 4 minus 6.25, which is minus 2.25 raised to power of 2. Now, the next thing is to square each value here. Don't forget that this dot represent other value here. So now from this point, we have v equals to 3.75 square will give us 14.06 plus 18.06 plus 1.56 plus dot plus the last value here, which will definitely give us 5.06. So now we have v equals to, if you add up all this value here, if you add everything together, we're going to have a 12 point, sorry, that is a 120.22. So we have 120.22. So this is our total variation. So after this now, we need between variation between, and this will give us, this is the formula. So we have a b summation j dot into bracket x bar j dot minus x bar all raised to power 2. The x bar j dot means the mean of each group. Now group A, we need the mean, another will get the mean. The total here is 26, and for us to get the mean, we have how many observations? 1, 2, 3, 4. So definitely we are going to have 26 divided by 4. So by the time we do that, we're going to have 6.5. We say 26 divided by 4 give us this value, which is 6.25. Now for here now, 18 divided by 4 will give us 4.5. What we do here is 18 over 4 give us the mean here. And finally, we said for 31 we have a 7.75. Another we get at, we say 31 divided by 4, the number of observation. So each value is 6.5, 5.4, 7.75. We're going to subtract each from this general mean here, from the ground mean. And if we do that, we're going to have this equals to, don't forget we have b here, and our b is 4. So we have a 4 into bracket open, 6.5 minus 6.25 raised to power 2 plus 4.5 minus 6.25 raised to power of 2 plus the last value here, 7.75 minus 6.25 raised to power of 2. Then we close the bracket, and from here now we have 4 into bracket 6.5 minus 6.25, that will give us 0.25 raised to power 2 plus this minus this, we're going to have minus 1.75 raised to power 2 plus 7.75 minus this, we have a 1.5 squared. So we'll close the bracket, and finally from here we have 4 into bracket 0.06 plus 3.06 plus 2.25. So here you have 4 equals into bracket. If you add all this up now, we have 5.37. So finally, 5.37 times 4 will give us 21.48. So this is our variation between VB, variation between. Now finally, we need a variation within, which is equals to V minus VW, and this is equals to our V, which is 120.22 minus VW, and that is sorry, this is VB, variation between, and our variation between here is a 21.48. So if we subtract that, our VW will be equals to 98.74. 98.74. So for V total, we have this value. For V between, we have this value. And finally, for V within, we have this value. So the next thing is to prepare ANOVA table. So from here, our ANOVA table, so here we have a variation. Let's make it big so that we can see it well. Variation. So this is variation between, and the value for variation between right from here is a 21.48. So here we have a 21.48. Now the next row we have a variation within, and our variation within right from here we have 98.74. So this will give us 98.74. And finally we have total variation, and our total variation is 120.22. So we have a 120.22. So that is that. So the next one, we have the degree of freedom. Degree of freedom. And we should not forget the degree of freedom for VB is A minus 1. We have a minus 1. And we already stated that our A is 3. A is 3. So we have a 3 minus 1. This will give us 2. So that is what we are going to have here. So we have a 2. And variation within. The variation within will be A into bracket B minus 1. And we should not forget that our B is 4. So here we have 3 into bracket 4 minus 1. And definitely 3 into bracket 4 minus 1. That is 3 multiplied by 3. And this will give us 9. And finally, total degree of freedom, which is given as AB minus 1. 3 times 4 will give us 12. That is 3 times 4 minus 1. 3 times 4 is 12 minus 1. So here we have 11. And if you look at it very well, if you add these two together, we're going to have 11. So the next column, we have a mean square. We have a mean square. So how do you get our mean square? This value divided by this value will give us this value here. That is VB VB divided by 2. Let me put this somewhere. So VB, that is 21.48 divided by 2 will give us this column. So 21.48 divided by 2 will give us 10.74. 10.74. And here 98.74 divided by 9 will give us 10.97. So there is no need for us to find the total mean square. So now we move to F. That is F statistics. And how do we get F? This box divided by this box. That is 10.74 divided by 10.97. And this will give us 0.98. Is 0.98 with 2.9 degree of freedom. So it will give us 0.98 with 2.9 degree of freedom. And what is our hypothesis stating? The null hypothesis. The null hypothesis states that there is no difference among group mean versus the alternative hypothesis H1, which says there is difference, there is significant difference among group mean. There is difference among group mean. Now here we need our conclusion. So it's a decision. How do we take our decision? We just say if f calculated, the one we calculate here, is less than f tabulated, and f tabulated is the f alpha, that is level of significance, comma the degree of freedom, and our degree of freedom here is 2, 9, and we should not forget that our alpha is 0.05 level of significance. So if our f calculated here is less than f tabulated here, what do? We accept H naught, that is the null hypothesis. Now if we now check this f here, that is f of 0.05, comma degree of freedom 2, 9. If you check the f table, we need to look for f table. So if you now look for the f table and we say f under is 0.05, then we check the column 2 and the vertical 9. The vertical 9 and the row 2. So this is going to give us 4.6. 4.6 from the F table. Now, what do we see here? We can see that our F calculated, which is 0.98, we say F calc, which is 0.98, is less than F tabulated, which is 4.26. So, what kind of decision do we take? We accept H naught, and the fact that we accept H naught, what does that mean? It means there is no difference among the group mean. There is another way of solving this. In the next video, I'm going to show you how to handle one-way analysis of variance using different formula. Thank you for watching.